Look at this distribution graph. Where is the numerical value that gives us the center point of the data? Do I put it here, here, or here? Well, all three of these lines are the center points. How? Well, welcome to part 2 of descriptive statistics, where we're going to learn about mean, median, and mode. Let's first start with mean. Mean is the sum of all measurements divided by the number of measurements we have. Mean is also the same thing as the average. Let's take those 25 students' grades from our last video and solve for the mean. If we plug all our number into a formula, we get 68.72. The mean also follows linearity. Here's an example to show that it's true. Another way of finding the mean is the weighted average. Let's turn back to our frequency table. Now we divide the frequency by n, or 25 in our case, and get the relative frequency of each bin. Now we take the average of each bin and times it by the relative frequency to get our mean. But what if we don't have the true average of each bin? Well, we can estimate the mean by using an approximate average of each bin. For example, bin 91 to 100, we get an approximate average of 95.5. Let's do that for all of the bins. We get 69.1. If we calculate the percentage error, we get a percentage error of 0.553, a value very close to the original, and a good way to get an estimate of the mean. Now let's move on to the median. Median, the value that is the midpoint of the frequency distribution of the observed values of the collected data. In other words, we take the data in increasing order and find the value which is the midpoint of n and 1. Our data had 25 entries, so is the 13th spot, which is 71. But let's say we didn't have the 16 and we have 24 entries instead. What is the median then? Calculating the midpoint, it is 12.5, so it's the average of the 12th and 13th spot. In this case, it's 73.5. Now let's move on to the mode. Mode, the value with the highest frequency. To find the true mode, let's look at the dot diagram. We see that the points with the highest frequency are 71, 76, and 80. We can estimate a singular mode if we use a histogram. We see that the highest bin is 71 to 80, so we would estimate our mode as 75.5. Let's go back to our graph from the beginning. This is the mean of the graph, this is the median, and this is the mode. In a symmetrical distribution, the mean, median, mode are the same value. If the mean is less than the mode, then it's a right-skewed distribution. If the mean is greater than the mode, it's a left-skewed distribution. In the real world, our three center points are often never the same value, but if the 3 points are very close to each other, we can believe that it's a symmetrical distribution in the whole population. Lastly for this video, sample percentiles. Let p be a percentage between 0 and 1. Let x of k be the kth value of the data in ascending order. Then the 100p percentile is the xk in which for an n-size dataset, or at least n times p of the values are less than or equal to xk, and at least n times 1 minus p of the values are greater than or equal to xk. In order to find k, we first need to talk about the equation y equals u times 1 minus p plus vp, where u is less than v. If the distance of u to v is d, then the distance to u to y is dp. With this equation, we can find the 100 times p percentile when we use 1 and n in this equation. So our equation changes to this, 1 minus p plus np. Let's try it. Let p be 25%. Then k equals 1 minus 25% plus 25 times 25%, and that equals 7. Therefore, our 25th percentile is 55. Let's try again with p equals 10%. We get k equals 3.4. How do we find xk this time? Well, using the same fractional distance formula, we can change it to this. Well, doesn't that look complicated? But let me explain. K-floor is the floor function of our K. For example, 3.1 will turn into 3. Similarly, our ceiling function will turn 3.4 into 4. K-decimal is simply everything after the decimal point, so 3.4 will turn into 0.4. x3 is 43, and x4 is 49. So plugging it all into the equation will give us xk equals 45.4. The most important percentiles you will see are 0, 25, 50, 75, and 100. Zeros is the minimum value of our dataset, and 100 is the maximum value. 25, 50, and 75 are called Q1, Q2, and Q3 respectively. These are called quartiles. The 50th percentile is also the median we talked about earlier in this video. Now you know the mean, median, mode, and some things related to them. Next time we'll learn about the spread and variability and some interesting properties with them. See you then.